So, hello everyone, we are back with the new video which is Naïve Bayes classification. So let's get quickly understand the topic here. It is a very easy and one of the simplest and common uh, algorithms for classification we use. So it is a family of algorithm where all of them shares a common principle, which is that every pair of feature being classified is independent of each other, which means they do not impact each other performance. If there are three variables or features, I should say, then they all are independent. They are all contributing individually in the model equally. There is nothing we can say that if the two features are contributing more than one, so here every feature available will contribute to a model performance or the accuracy. So the naive Bayes algorithm is used for the classification problem. It is highly used in the text classification, high dimensional data. It is used in the spam filtering, sentiment detecting, rating classification, etc. The advantage of using naive Bayes is its speed. It is fast and making prediction easy with high dimensional of data. Basically, it's the key point or the highlighting point is that it can work well for the high dimensional data and it is easy to use. So both works at the same hand. When we have types of naive Bayes classifiers, which is the Gaussian, which we use for the continuous data and assumes a normal distribution. And we have multimonial naive Bayes, in which we have used the discrete data, basically used for the text classification. Then we have Bernoulli naive Bayes, we use for the binary data. Then we have the application of naive Bayes, which is in the Python. So this is the whole snippet of the code. Let's go through once, and you can use this code in your IDE, maybe Jupyter Notebook, Anaconda, or anything you use. Basically, we are importing all of the sklearn, which is the scikit-learn. It is the powerful library of the Python, which contains many functions. Like we are using a train test split, which is I have mentioned previously, which is the whole data set we divide into two, basically training data set and test data set. Training data set we use for the uh, training of the model. So by the train test splits function, we can split our data into our choice of quantity, maybe 70-30 or 80-20. Then we are using the multimodal NB, which is the function of the naive Bayes, and we are using the count vectorize, which we'll use for the training of the model. We'll fit that. Then we have accuracy score and the classification report, which is the matrices to evaluate our model. So here, uh, first we have initialize our count vectorize into a variable and fit our model, which is the text here. Then we have split our data into training and test sets. Then we have um, put our model into the naive Bayes classification function. Then we have used the matrices to check the accuracy and correctiveness of our model. Then what is the theory of naive Bayes? This is the formula for the naive Bayes and the basic principle of the naive Bayes, which is the probability of two events. Basically, here are two events A and B, where probability of B should not be equal to 0. Then basically we are trying to find the probability of event A with respect to B, and B is always true. And B can also be termed as the evidence. Here, probability of is the prior of A, which is the probability before the event is seen. Then probability of B is the marginal probability. Then probability A by B is the posterior probability, and B by A probability is likelihood probability, in which that is the likelihood that a hypothesis come true on the basis of the evidence, which is the probability of B. Then what is the advantages here is that it is simple to use and it is easy. It is very effective in the large data sets and it works well with the high dimensionality data. And here are some of the disadvantages. Basically, every feature is independent, so it can sometimes lead to the misleading results for the model. When we have the poor performance, when predictors are highly correlated, definitely it is one of the problems. And thank you. I hope you guys have understood the basic concept of naive bias, what it is, and in which cases we should use naive bias. So thank you.